Hi everyone, this is Miss Moriarty, and I'm here to discuss with us the very last topic of Unit 9 for us, which is the impacts of mining. So we talked a little bit about this in class today prior to our mining activity, but I just want to reiterate, right? Remember, the reason why that this topic is found in Unit 5 is because mining for certain materials is a part of how humans are going to use land and how they're going to use those resources. On a daily basis, you pretty much use materials that have been mined for all of the time. Because if there's something that we need, a product that we need that can't naturally be grown through vegetation or potentially synthesized in the lab, we need those resources mined from underground. Now, the pieces that we mine underground, we tend to call ore. Now, what would be the definition of ore? That would be any concentrated accumulation of minerals. So, when we mine for ores, we can find things like metals, like copper and iron and nickel. We can also find things like sand or even salt, as well as fossil fuels. So mining can kind of encompass obtaining each and every one of those types of materials for a product that we might need on a daily basis. Now, types of mining that we should know, two types are surface mining and then subsurface mining. In this first slide, we'll talk about the types of surface mining, and you can kind of see them in the image there. But what does surface mining mean? It means the removal of those ores or minerals that tend to be closer to Earth's surface. But to do that, a very large amount of soil and maybe even rock, called overburden, will have to then be removed. Now, the first type of surface mining is called strip mining. You can see that here. So this is actually moving strips of soil and or rock to expose the ore. This type of mining tends to be used when whatever we're trying to find is pretty close to the surface. Afterwards, when that ore is then mined, any material that is then unwanted tends to be then put back into place as best as possible. But unfortunately, it's not always perfect. And the other materials that tend to go unwanted, we're going to find that they're going to be called tailings. And you're going to see that word kind of pop up multiple times throughout the video. Now, on the other types of surface mining, open pit, mountaintop placer, open pit mining, you can see that here. You can see that here. This is the creation of a very large pit or hole underground. Oftentimes, we tend to mine for copper using open pit mining. They can go as far down as 100 meters deep, which equates to about 328 feet or so. Looking at mountaintop removal, this is actually using explosives to remove the entire top of the mountain, and then it is hopefully put back to the best of its ability at the end. And lastly would be placer mining. This is actually going into like a river or say like a stream and filtering out materials like sediments to then find things like metals or gemstones. Type of mining is called subsurface mining. This is where we tend to mine for resources farther below Earth's surface, so about 100 meters or so deep. How does subsurface mining work? What tends to happen is horizontal tunnels tend to be dug usually within a mountain of some sorts, and then vertical shafts are then dug through in order for miners to carry back and forth whatever the resource might be that they are mining for. What tends to be mined for when we use subsurface? That would be things like coal, diamonds, and even gold. So it's important to note as our reserves of those resources, especially coal, since we know coal is a fossil fuel, provides energy. As those coal reserves get smaller due to a lack of easy access, subsurface mining is going to have to become more prevalent. But Subsurface mining is more expensive than surface mining. It takes more materials. You're going farther into earth, tends to be a little more dangerous, and has the potential to produce even more waste than surface mining. So it's important to note, as the more accessible ores are mined to their depletion, mining operations will be forced to access then lower grade ores. But when we do that, we then must continue to change our methods, which can potentially increase waste and pollution. And economically, it might actually force those materials that usually are at a low cost to then increase their cost because now it's that much more expensive to access the better quality ores. Now, besides the economic impact of mining and the types of mining, we need to know its environmental impacts. Specifically, looking at the environmental impact of refining those metals that we tend to mine for. I said previously, when an area is then mined, we tend to also have unwanted parts of that soil and rock. Now, those unwanted parts are called mine tailings. Those tailings can actually contain toxic materials like cyanide, mercury, sulfuric acid, which usually, after an area has been mined, can usually be left in a pile or maybe even near a pond. The then plants that take those ores and smelt them into other materials can produce large amounts of air pollutants. They can release things like sulfur, which can form sulfuric acid, leads to acid rain, can also contain things like heavy metals like lead, cadmium, arsenic, and zinc. And on top of that, it also requires energy. So let's compare the two. Right? If we look at both of our mining operations and their effects on air, we know surface mining, because it's much closer to Earth, is going to probably produce a lot of particulate matter. That would be our dust, versus subsurface mining, not really going to produce that dust because now we're going deeper into Earth, but the emissions from using the machinery involved will produce fossil fuels. Looking at its effect on water, we can see contamination of water that percolates from those tailings could happen. We can also see what's called acid mine drainage, which I'll talk a little bit about, can contaminate, once again, water through percolation. The effects on soil. We know that in surface mining, we're going to be removing some of the soil from the surface, versus in subsurface mining, we tend to not really remove that soil so much as then really just dig into it. Biodiversity. Definitely going to see habitat alteration, destruction as a result of surface mining. Subsurface mining, you may not see that much impact on its biodiversity besides maybe the construction of roads for the machinery used. And what about the effects on humans? Nearby, maybe a surface mining plant. You might see a decrease in air quality, water quality. In subsurface mining, if you tend to work as a miner, it is potentially hazardous, could cause respiratory diseases, and so on. So each one tends to kind of have their pros, while each one is going to have their cons. And so now looking just overall at each one, right, and its environmental impacts, we know that either one, subsurface, surface, will disrupt a large area. It's going to destroy the existing vegetation, which can create more erosion. They can also use large quantities of water, and the reason being, water tends to be pumped out of the mine in order to try to keep it dry, especially in subsurface mining. Using that water is going to deplete then the water table. It might even deplete the water nearby for maybe an agricultural field for irrigation. Some environmentalists would actually like mining companies to re-inject whatever water that they've previously used back into the ground after they have pumped it out, just to try to minimize the water use. But overall, what does mining do? It can destroy habitats, contaminate groundwater, released dust particulates, as well as fossil fuels such as methane. The last thing that I'm going to leave you with today is going to be what is acid mine drainage. Now, I'm probably not going to put a question about acid mine drainage on our test on Thursday, but you will see acid mine drainage come up again, especially in Unit 8. So look out for this topic then. But what is acid mine drainage? This tends to occur in subsurface mining. This is where rocks that are very rich in minerals tend to contain high concentrations of metals like arsenic and lead. When rainwater tends to seep through those lead minerals, exposed in whatever waste may have been collected, sulfuric acid can be produced as a result of the mixture of those sulfur minerals and water. This can dissolve other toxic substances found in the rock, like lead, arsenic, or cadmium. Then the mix of the toxic substances and all of those acids create this really toxic mixture that can wind up in the soil or even the groundwater. So you can kind of see that in that image here. Now, obviously, this is going to affect any nearby aquatic life. How might you prevent this? The rapid drainage, maybe during a thunderstorm or spring melt. As you can see that this is going to affect aquatic life, right? The mixture of acids and high toxic substances is definitely going to wind up in the intolerant zone for those organisms. And although a mining company can reclaim the land, they're still going to have these materials remaining. And even though it might affect the ecosystem in that short period of time, you can actually continue to see this affect the ecosystem years later. Because during things like thunderstorms or lots and lots of spring snow melt, it can create these things called toxic pulses, in where the water found underground still contains a lot of those toxins or acidity, and once again impact the wildlife in that watershed. All right, guys, that is it for our video today. Please make sure as you watch you are taking notes, and please mark this as done when complete.